In this video for Positive Maths, we're looking at the Junior Cert Higher Level 2014 sample paper. This is question 13 from paper 1. A rectangular site with one side facing a road is to be fenced off. The side facing the road, which does not require fencing, is L meters in length. The sides perpendicular to the road are X meters in length. The length of fencing that will be used to enclose the rest of the site is 140 meters. So before we start doing the questions, I'm going to go back and highlight some key pieces of information. So it's a rectangular site. The side facing the road does not require fencing. L meters in length. We have X meters in length for the sides that are perpendicular. And the length of fencing will be 140 meters. So because it's a rectangular site, it means that this side is also X meters, and the side parallel to the road is also L meters. So part 1 wants us to write an expression in terms of X for the length L of the side facing the road. So what we're going to use is the information that the total length of the fence is 140 meters. So we know that 140 meters is equal to 2x plus L. So we're going to use this to write our expression. So 140 minus 2x is equal to L. Part 2. Show that the area of the site in meters squared is minus 2x squared plus 140x. So I'm going to draw a quick sketch of the site. So I'm doing this because I don't want to draw too much on the diagram that I'm given, because it might make it a bit messy. I won't be able to read it clearly for other parts of the question. So here we have L and we have X. We also have L in terms of X. So instead of using L, we're going to use 140 minus 2x. We're doing this because we notice that we need to write the area just in terms of x without L. So here we're going to note the area of a rectangular shape is length multiplied by the width. So in this case it's going to be x multiplied by 140 minus 2x. So if we simplify, we get 140x minus 2x squared. And that's what we wanted to show. Show that the area of the site in meters squared is minus 2x squared, 140x. So just for our final answer, we will put in our units m squared. Part 3. Let f be the function minus 2x squared plus 140x. Evaluate the f of x when x is equal to 0, 10, 20, 30, 40, 50, 60, and 70. Hence, draw the graph for f for x is greater than or equal to 0, less than or equal to 70, when x is a real number. So first of all, I'm going to just underline the function that we're given. We need to evaluate it, and hence draw the graph. We're given the domain, 0 less than or equal to x is less than or equal to 70. So the first thing I'm going to do is just write out my function again. So we have minus 2x squared plus 140x. So the way that they've written it here is the exact same meaning as this here. So we use f bracket x. So we need to evaluate it when x is equal to 0 first of all. So the f of 0 is equal to minus 2 by 0 squared plus 140 by 0. So the f of 0 is just equal to 0. The next one, the f of 10. So we're evaluating the function when x is equal to 10. So minus 2 by 10 squared plus 140 by 10. So we're going to get minus 200 plus 1400. So we get 1200. Next one we have is the f of 20. So we do the same. We fill in 20 for x. So minus 2 by 20 squared is going to give us minus 800. 140 by 20 gives us 2,800. So the f of 20 is equal to 2,000. The f of 30 minus 2 by 30 squared plus 140 by 30. We get minus 1,800 plus 4,200. So we get 2,400. Next one, the f of 40 minus 2, 40 squared plus 140 by x. So we get minus 3,200 plus 5,600. So we get 2,400. The f of 50 minus 2 by 50 squared plus 140 by 50. Get minus 5,000 plus 7,000. So we get 2,000. The f of 60 minus 2 by 60 squared plus 140 by 60. We get minus 7,200 plus 8,400. So we get 1,200. And our last one, the f of 70 minus 2 by 70 squared plus 140 by 70. We get minus 9,800 plus 9,800. So we get 0. So we now have the points that we need to draw the graph. So what we need to remember is that when we put x into a function, we get out a value for y. So our first point, x is 0, y is 0. X is 10, y is 1,200. Next one, when x is 20, y is 2,000. When x is 30, y is 2,400. When x is 40, y is 2,400 again. When x is 50, y is 2,000. When x is 60, y is 1,200. And when x is 70, y is 0. So now we need to draw our graph. So the first thing we do is draw our x and y axis. So I've really only drawn the positive sides for the x and y axis because we only have positive values for x and y. So we start off, we need to put 0 to 70 on the x-axis and 0 up to about 2,400 on the y-axis. Now we just plot our points. So we have 0, 0 for the first one, and we have 10 and 1,200, 20 and 2,000, 30, 2,400, 40, 2,400, 50, 2,000, 60, 1,200, and 70 and 0. Now we join up our points. Part 4. Use the graph from part 3 to estimate the maximum possible area of the site. So what we want to note is that in part 2 we showed that the area of the site is minus 2x squared plus 140x. So that is the function which represents the area. So then we graphed the function. So in order to find the maximum possible area of the site, we need to go to the maximum point on the graph. So that is approximately here. Now when you're doing this yourselves with graph paper, it's a little bit easier to estimate, but we're going to get as close as we can. So what we're noticing is that it's just above 2,400. So if we draw our line over to the y, now we need to estimate. So approximately halfway here is going to be 2,500. So if it's about 0.2 of the way up, then it's going to be 2,420. So we're estimating the maximum possible area. So our answer is going to be 2,420 meters squared. Now we need to estimate the area of the site when the road frontage, or L, is 30 meters long. So in order to estimate the area when it's 30 meters long, first of all we really need to find x. So write down when L is 30, we have 30 is equal to 140 minus 2x. So 30 minus 140 is equal to minus 2x. Minus 110 is equal to minus 2x. So minus 110 divided by minus 2 is going to give us x. So x is equal to 55. So when L is 30 meters long, x is 55 meters. So we go to 55 on our x. We go up to our graph. When the line hits the graph, then we go over to our y-axis. So again, it's just above 1,600 meters squared. So we'll say the area is equal to 1,620 meters squared. For more information, visit PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter. Thanks for watching.